It's good.
Thank you for the pizza, Dana.
You're welcome. Kelly's back on the team,
Okay.
and we're doing a split classroom environment with students. So like
You
one's
did
front
Pratt
end,
0923 Gmail, right?
You didn't get it?
then they
Did you get my invite, David?
Okay.
In Gmail?
It'll probably come soon.
And then they can opt into a month of their final project.
I didn't. So you do the whole thing after the project.
Hey, Dana? What's the TIY Turing password again?
It is capital TIY, the Turing 16, right above Turing's.
Oh, I was looking for it because you always leave it up. And I haven't had to look at it, I guess, since it was over
No
there.
way you did over there.
Thanks, Dana.
Do you know if maybe that or Catherine got that AT&T job?
Both of them did.
Both of them did. Cool. That's good.
So her Katie got it, but then everyone else was very good.
Awesome.
Awesome. So maybe somebody else.
I don't know why I keep professional. It's not like it matters. I got it.
So her Katie got it. Johnson said.
Oh, that's right.
How are things on you, David?
They're going all right. I like where I'm working. I like people I work with.
Around and face to that
And sound as well?
at my.
Or that's camera?
No,
Oops.
yep.
Oh, there. Share your screen.
How do I do that? Do you know where I go for that?
Maybe that green button.
Okay.
Yeah. Oh, that's why. Maybe you are sharing your screen.
You are screen.
Right, I see. Okay. Perfect. And then I think you can go full screen.
Alright.
Oh yeah, and David was cohort 1, Rails, and has been, have you been at this place the whole time since you graduated?
Yep. Or, well, as long as I got the job after I graduated. It took me a bit to go into it a little bit.
Great.
That's an introduction.
Thanks.
All right. I think we're good on all the Google Hangout stuff.
Yes, thank you.
All right, yeah. Like I said, I'm David Marshall. I was in cohort 1, the Ruby on Rails class with Clinton. I'm at Webinize Lab right now, or just Webinize now. We're small, well, smaller in this country, in the area, just custom software solutions company. I've worked at a couple different clients on a couple different things. A little bit of Ruby on Rails, although for the past about year and a half, I've been primarily essentially a mobile developer, with a little bit of back end and a little bit of front end and a bunch of different things. So today I'll be presenting on this serverless application with AWS Lambda. I know the last talk I was at, I think it was in March, was regarding, I believe, Alexa, which also uses AWS Lambda. So hopefully if anyone was here for that one and is still here for this one, definitely enough of an overlap that I think you'll still get to see a lot about how that's used a little bit differently, and kind of the similarities as well. So, and if not, this might be new to you, or it might not.
What is AWS Lambda?
So it is a service by Amazon Web Services, and I can go into, I've got a page on that. You're good. No, actually, I was about to say, at any time if you have a question, go ahead and feel free to interrupt me, and I will answer it to the best of my ability. On as deep as you can go on this. What I'm going to show you is pretty much, specifically the serverless application is a REST API. So it will act as a microservice. And I think that's kind of one of the neater things you can do with this service, one of the most applicable to real situations, like real development situations. And something that's relatively new. There aren't a whole lot of competitors for it right now. And overall, it's pretty neat. And just, I'll probably mention it a couple times, kind of why I've decided to go with this. My company right now is I'm working with one of our larger clients, and we will be implementing this in the future. So I was learning it over these past couple weeks, and I decided to go ahead and use that and kind of, have double motivation for learning how this works. So I might mention that going into the presentation, kind of what that use case is and kind of how this could be used. Yeah. So the topic specifically I'll be going over is I'll go over a brief overview, as well as specifically the AWS API Gateway, the Lambda function. I will show you a demo. I'll go over some of the other services. Specifically, Google Firebase is one of the services. I'll go into why I decided to use Google after sticking with Amazon on the previous 2 services when I get there. Mostly it's because it's easy. So always good. And then I'll open it up to questions. So quick overview on what is serverless. So it's cloud computing code execution model. And that's pretty much the first thing you're gonna read on Wikipedia. And it's function as a service. So essentially the cloud is gonna host your function. And within the cloud itself, which within this, infrastructure that these different companies, and there's companies that can do it. Google does it, IBM, Microsoft, and of course Amazon all have the capability of being cloud companies. So they'll host your function and then essentially spin up a server. So serverless is kind of a misnomer, but they'll spin up a server, execute a function based on an event, and then they will, once the function is complete, they'll kind of spin down the server and basically remain idle. Your function will remain idle unless it's used again. So like I said, it's not exactly serverless. The code's still running containers. You're going to Amazon will spin up a container when running Lambda, but there's not one that's dedicated to it. And especially in terms of being a developer, there's not one that you specifically have to maintain. And that brings me to actually why go serverless. So the benefits of using the serverless backend, like I said, it's easy to maintain. With easier to maintain kind of infrastructure, there's a lot more time spent dedicated to actual coding. You can specialize in coding rather than, well, there are a lot of tools available kind of to make deployment and setting up servers easier, spinning up virtual machines, spinning up different servers. So you can focus less on that and more on actually getting your code correct. What's that?
When you said it runs a container, is it really a Docker container, or does Amazon have its own version of it?
It's an EC2, I believe.
Oh, okay.
So like a specific, just pretty much a normal instance that you would get through Amazon will kind of spin up. I don't know the entire nitty gritty of it, unfortunately. Like I said, I've not gone very deep, and I believe a lot of that Amazon considers proprietary. But I mean, regardless, you can't really go like completely serverless, because that'd be some magic.
And you don't need to know.
Yeah, that's true. It is definitely abstracted all the way to essentially the code, which, it has its own benefits and costs, but still, what you use to set up, like setting up, Linux and, whatever you're running on, whatever server you're hosting your services on, exactly. So in terms of like specific maintaining, Lambda is auto scaling. I believe I have the specifics somewhere, probably in the Lambda section. But essentially, and a lot of this is also in the second bullet, cost, pay for what you use. But essentially, unless you're using that specific function, unless there's an event requesting you have hosted, your code will not be in use. So say, you only have, 10 requests per day because you're a very small company and, not a whole lot of people use what you're using or use what you're doing right now. On a traditional server, you're still paying for that idle time that your code is not being used. With Lambda, it's only used, and with serverless, it's only used when it's needed. The load balance, specifically like having different, that's for, well, I guess, sorry. you don't need a load balance, which is pretty much very similar to that. If you have different servers redirecting different requests, that's just completely wiped out by Lambda. No security patches. Like I said, you don't really need to maintain for that dedicated server, specifically with like Linux or whatever you're running. It also has some easily built-in monitoring tools. So, if something's wrong, if someone's hitting your API way too much, you'll be able to tell basically with the tools built in with Amazon. Or specifically, actually, not just Amazon, with the alternatives as well. Like I mentioned before, it's cost effective. You pay for what you use. I believe the rate for Lambda is like by request, and you get the first 1 million requests free. And after that, I think it's 1 million requests free per month, and after that, it's 0.0000002 cents a request. So if you're a small company and you don't get that many requests, you're a startup, that's not going to be a prohibitive cost for you. And it's actually kind of strange because it's kind of cannibalizing a little bit of their own business, though it is actually more cost effective. Last one, more easily implementable services microservices architecture. Specifically, this is more, you can do this with dedicated servers as well. You can implement a service or microservice architecture, basically small dedicated portions of whatever application you're running that shall essentially decouple from the rest of the main application. Very small API running on Lambda that serves your greater application, and it's more easily maintained by, say, running a Lambda function gateway than it would be to do it on a dedicated server that would normally run it. So it makes running a more efficient architecture easier. All right. More interesting when I actually get to these tools, but bear with me. Specifically, going to talk about AWS Lambda. It was introduced in 2014. Like I said, it was serverless and event-driven. And it's also able to use multiple languages. Node.js is what it started with. It has since added Python support, as well as for JVM languages, Java, Scala, whichever one, JRuby, and I believe it has support for C# now. And specifically, well, I'll get into that later, actually. So essentially, AWS Lambda was created to be an event-driven compute service, which means that of all the AWS infrastructure services, specifically like S3, Dynamo database, and even Alexa, the Echo, whenever they had an event within their infrastructure, you could call, or it would call Lambda and it would run a function. So say like something was uploaded S3, you could hook Lambda up to that and run some sort of function on that upload. Or anytime something was added to Dynamo database, you could do the same. What really made it powerful was when they added support for API Gateway, which allowed for RESTful APIs to be built using specifically AWS Lambda. So yeah, like I said, when the function is called, it's provisioned to the Lambda infrastructure and then run. When it's called multiple times, it runs in parallel, so it is pretty efficient. And as I mentioned before, it is run in an ephemeral server, meaning that it exists for as long as it needs to exist. Some of the limitations you'll see in Lambda is that it can only run for continuously 300 seconds over 5 minutes. So you can't do like long polling. And any high performance computing will kind of suffer using Lambda. And one specific problem, nearly specific to most of the JVM languages, is that there's a little bit of latency when you're running, when it takes a while for, say, job to start up. But for most use cases, it is going to be pretty efficient. Right. And briefly, talk about AWS API Gateway. So this is RESTful API management. You can use this with Lambda. You can use this essentially with just regular HTTP or HTTPS endpoints. But essentially, it's a tool to help you with your REST API. It allows you to create a REST API, obviously do all the things, configure it, publish it, so it'll deploy it, maintain it is the big one, as well as monitor. One of the best use cases for it is the ability to dole out or give out API keys along with it when you secure it. So you can actually see based on that key if anyone is if anyone is kind of either attacking it or misusing it, and you can actually throttle them or in some cases revoke that API key. So it's pretty useful even apart from the Lambda functions. We're gonna kind of look and see how it works when they combine. So yeah, that was mostly my straight talking portion of the presentation. Hope you're still with me.
Yeah.
Not yet. Okay. All right. So I'm gonna go to AWS. Hope that I'm still logged in. I am. Should have done this before. So this is AWS API Gateway. You can see I have an API called Presentation API, specifically for this presentation. If I go here, I have one method right now, specifically post hello. I wrote the title before I knew exactly what I was going to do. Go here. So you can see on the left here, we have a list of kind of what's available to this API, resources specifically. Well, if you're familiar with Rails, you should be familiar with resources, specifically when kind of making your models, controllers, whatnot. But essentially, this is going to be what builds your endpoint. So if I were to build an endpoint, create a resource, resource name, greetings, resource. Oop, actually, I created that one for post hello, so I will delete it. But anyways, essentially, this is what builds your endpoints. Go in here. Why are these two different things? Specifically integrate the integration type. This one is located in to the Lambda function. You can do HTTP. You can do a mock endpoint, which is helpful in development. I've definitely had times when I was working on something and someone else was working on the back end and they were moving slower than I was and I needed their endpoint where this would have been helpful. You can also hook it up to a different AWS service. I'll quickly go through the rest of these on the side, stages, so you can create different versions. You're still there. Yeah, you can create different ones. Specifically, this one is develop. Just something I made. Authorizers are actually separate Lambda functions that will be called when when a request is made. They will run the request through the authorizer, and you can write custom code to determine whether or not they are allowed or if the request is valid. So that's pretty useful. Another way to secure the API. Models, of course, represent your data. It's pretty easy to explain. Documentation, it's actually pretty easy to document kind of what you're doing, how you're building your API. You can do it, I believe, for Swagger and other different types of documentations. And you can actually build your API out, say HTTP API, and import your Swagger documentation, and it will create the API gateway for it. Binary support, dashboard, just kind of shows monitoring. Is what I was talking about a little bit earlier in terms of kind of permissions. You can kind of see, I made this basic one. I don't know if any of these are valid or anyone would ever use it like this, but essentially you can only go 100 requests per second, 100 requests per burst, and 10,000 requests per day. Whether or not that's a lot or little, I wouldn't know. I guess it depends on kind of the way you're setting up your API. But you can actually assign these to different stages. You can assign them based on specific users. So you can really control who can access your API at all times, how much they can access your API. And you can really tell if they're in any way that you don't want them to. You'll be able to kind of secure it from them.
And what is a burst? How's it different than multiple requests per second?
That is a good question. I'm not sure. Token bucket. Yeah, I'm actually, I assumed it's multiple, simultaneous requests, but I am not sure. API keys, really going with the securing right now. You can create these and assign them to different users. This one is for Postman, because I needed that for this, not Postman. And you can see I add them to the usage plan basic, which I just showed you a second ago. These I've had less to deal with. Custom domain names. So you use your own domain name, client certificates, and just general settings. But that's basically kind of just a real quick overview of kind of the different ways, a little bit deeper into API gateway than I've gone. But hopefully, if you have any, it shows a little bit of kind of a glimpse of what it can offer. But specifically, I've made this post endpoint called post hello. So as I showed you earlier, it is wired to a Lambda function. The Lambda function is also called post hello. And we can go there now. So I'll show you. This is AWS Lambda. It's pretty straightforward. You're going to create functions and they'll show up here. So I've decided to edit my function specifically for today inline. There are a couple different ways you can do this. You can upload a zip file for Node.js. you can upload it either from your computer or host it on, say, I believe S3. But yeah, I will say, just as a warning, don't judge me too harshly on my code. I believe in iterative programming, and I did not have a lot of time to iterate over this and make it better. Right now, it just works. But yeah, I'm also not very creative. So I'm essentially one of the use cases that I've seen on kind of like a microservice API is the ability to talk to your own database as well as a third-party data source, someone else's API, essentially. And then send it back down to the client. It's a couple of what I will be doing when I'm building this later for my company. We're going to be talking to our own database and then to actually Elasticsearch. And so we're going to use a small just kind of API in front of that so that we can combine those two and we can just kind of use both of those data requests to send it back down to our essentially front end. And actually, I do want to mention, I guess, never mind. So for this one, I actually set up my own database, and I set up a connection to the API Jiffy because it has a public API with a public key, so it's pretty easy. This actually will never work. That's my fault. So anytime you make this, you can actually test as well.
So you can save it without testing, but they basically want to.
Yeah, you can save without testing, and this is going to fail because I tested with Postman, and Postman doesn't like some of the things that this inline does for whatever reason. Still working on a few things, I guess. We'll see. But essentially what I'm going to do is, what you do is you set up this exports.handler. This will be created for you whenever you make a Lambda function. And essentially it's what handles, it's what runs essentially when the Lambda function is called. The event specifically is the request. The context is it's essentially about yourself. It'll show some of your identifying configurations, specifically kind of who you are, where it's coming from.
Like the IP address stuff?
More like essentially Amazon's user ID for you.
Oh, okay.
And then callback is what you call, essentially it's your return function. So your callback is going to be called, and this is what is returned. So in this code, I am essentially so this is a post request, and I will show you. I did this one. So you've got your, okay, I'll get back to this, sorry. Mixed around here. So you've got your endpoint. This is the URL that Amazon will give you once you deploy, specifically here, where you deploy your API. You choose to deploy it to whatever stage you want. You can set your configuration variables based on essentially wherever you want to deploy this to. This will go on the API. And it looks exactly like this does. So this is all ready. When you click here, you can see your invoke URL. That is what I have here. So I'm taking 2 parameters in this post, specifically name and search. So I'm going to take the name of the person searching. This was done by someone I work with earlier today, and they were searching for unicorns. Very, very quickly, I throw the event.body, which is essentially those parameters, into request GIFs. I will parse that with JSON. This will never work now that I see this, so it doesn't matter. But that was going to be a guard clause to make sure that search exists. I have my path for the public API for Jiffy. I'm going to put it in this options object. And I'm going to use HTTPS, which I declared up here, to request, basically, based on the path, these parameters that I've included, 5 GIFs based on that string. So I declare a response body, essentially add all the chunks that come in, and then parse that after it ends, after the quest ends. Parse that. Yeah, so I parse the images based on kind of where they are in that big data that I get back, because I get a lot back from them. So I get the image URLs, I parse. Yes. Sorry. I parse the body again, essentially the body of my request. And then I write them to my database. So we've already kind of made one request. We're already transforming some data. But of course we could do that from whatever application we were originally going to do that. To, I guess, whatever database you want. Specifically, I've chosen to do Firebase, mainly because I can show you immediately what it is, which is right here. Also because I'm comfortable with it. Firebase is essentially a kind of infrastructure of services that Google uses. They have specifically a real-time database, which is very useful, especially when you're dealing with mobile projects. Usually it's a NoSQL database. It pretty much it's very similar to JSON. It just uses different keys. Any search that I've added in here, or any search that I send here, I will write API, although they have different packages and different services based on kind of whatever you need. They have a JavaScript interface as well as Swift and Android. It was just easier to do the REST API. So anything I send here, success, will end up right here. So let's see. May, do you have a search term?
Oh man, rainbow.
Yeah, I did make these rated PG because anything embarrassing coming up on here.
I like David Gold, David Silver.
Yeah. So you can kind of see down here, go away.
Like, hi.
So yeah, you can see down here, we have 5 GIFs based on this post request that I've sent to API Gateway to post hello. Go through here. Sometimes it takes a lot of clicks to get where you want to go. So obviously the client, specifically Postman, in this situation, sends the request to API Gateway. When it receives the request, that's the event. Spins up the server, spins up the Lambda function called right here. It'll run the Lambda function, and in this case, it actually went to Jiffy as well as Firebase, and then it sends it back through me, sends it back through the callback, through the API gateway, and you'll see that right here it just says success. That's kind of all I wanted to do right now in this callback. And it ends up, whatever Jiffy sent us ends up right here. So there's another way to show this as well. I spun up a little bit of a...
I was hoping to see them.
Oh, weird. Interesting that rainbow and unicorn are the same one. That's funny. So I made a small React app just to kind of show you the GIFs, and there they are. And there was my previous search. I don't know, but oh, what? Oh, there we go. Yeah, and a little bit off track. So the reason I didn't have to reload the page is because of Firebase. Firebase is a real-time database, which in this instance means that to read kind of what I have, what's in data, I essentially, sorry, let me go here.
It's not because it's a React app?
It is partially because it's a React app, but it also would work the same if it was in Swift or Android. Essentially, when you go to do a GET using the Firebase package that you give a node, it essentially calls an observer and just does a straight GET request for the changes.
And that's what that means by real-time service?
Yeah, it'll send down kind of a, it sends down some sort of small token and then essentially says, hey, I got something new, so come get it. Mobile as well. So I put this in there also partially because if anyone else had seen this serverless application, Firebase is really cool. So
Yeah,
they can take that. They can take that away as well. It's pretty neat.
What's the pricing on that?
Firebase, because this is free, at least right here. You just sign up. I'm sure they go into pricing with more support and more requests. Right now, I've only used it for very small things. It's actually really neat. You're doing mobile, and once again, this is a little off track. But if you're doing mobile and you say like declaring like constants, this is very useful. And like declare static constant files within your own app. Unfortunately, some people in my company have a to the extreme. My constant file is probably the biggest file in one of my apps. That is kind of specifically, that's what it is all put together, just showing kind of how it works as an example. We would go ahead and run, and by that I mean a method that I have come up with, how I will do it. Anyone have any questions as of right now? Sure.
So it looks like you've got bits of code and configuration kind of all over this web interface. Like, how do you control?
Yes. So you can save it. Oh, no, wait. There are ways to do this, and I was looking for this today. Versioning. So there is versioning here. Normally, I would say, I'm really kicking myself because I made it.
Is it a CloudFormation template or something? And
Wait. Using that somewhere. Tags, functions, configuration. Crap, where is it? Yes, there are ways to. Integrate it. Although I would say that if you want a version, I guess, yeah. There's definitely a way to version it on this web interface. I do not know it, unfortunately. I've explored a lot around this, but unfortunately I haven't gotten there. My thing would be, I would probably try to upload your node, do a zip file, and then just do a version in a similar way, like with obviously with Git. There is a way to do it, and I'm not sure, unfortunately. Sorry about that. I kicked myself too, because I thought about that earlier today. And now I feel like a dumb. Yeah. Did anyone else have any questions about anything they've seen so far? All right. All right, well, let's go ahead and do a Lambda function of our own. So obviously you've seen seen all this already. So you've seen kind of the parameters right here, our name and search. You've seen that I've been able to get all the GIFs down at the same time. So I'm going to do a GET request specifically by name. So first off, I will create a Lambda function. There are a bunch of different blueprints. Going Alexa scale. Specifically for the other services, I'm just going to do blank. So this is the trigger. As a way too much, it's triggered by an event. This is the event specifically. So the API name will be presentation API. This is what stage I'm in. And the security with access key. AWS IAM would be specifically for any users that have access to my open is obviously open. Open access key is what I want right now. So I'm going to name this, what was it? I'll do get by name. Description, don't need that. So this is what you get by default. Encryption helpers, index at handler. So if you were doing multiple node files, say, or multiple handlers, you can define them right here in this handler. Role is just kind of essentially permissions within your infrastructure. Those are easily created. but essentially it says that this is the role that will be executed, similar to any user that you would get on like when you SSH into a server. You have certain permissions of what you can and cannot access. This is very similar. So this is the one that will be technically executing this function, and whether or not it has access to different services essentially is how powerful the function can be. So this one is just my default one. It's post. Congratulations. All right. So you can see here that our trigger has already been set up, blank. But when we go to API Gateway, presentation API, presentation API, there we go. All right, get my name.
Right, because you haven't declared.
Yeah. So I probably did this, use Lambda proxy integration. So I click this. Essentially, that means that your request is sent to the Lambda function within event. If you don't use the proxy, it essentially only serves, it only gives you the body of the event. So when you do any, I will go ahead and show you. Deploy. You literally take the whole request and you can make any request to this endpoint that you would like. So when you take the event, it has a key in there that tells you what type of request it is. And you could say switch and do different things based on what kind of request you're receiving at the time. So I made 2 different Lambda functions. You do not have to do that. You could run an entire API within one function. It'd be a little messy, but actually I think most people do try to do that. So for cleanliness, I'm starting from scratch, but there are ways to organize the code that you could essentially do, any part of your API all from one node function. Specifically, right now, we don't really need to do an any method. We will be better off just doing get, because that's all we need. We don't really need to open up our API to any other extraneous requests that we're not expecting. So I will go ahead and do get. Function.
Programming by UI.
Lambda function. Oh, you know what Lambda function is. Come on. Yes. Okay. All right. So check out my little list here. I'm going to go ahead and redeploy the API to dev. And I'm going to go ahead and do, just make sure, security. Yes. That is not true. This needs to be. It looks like it reset a couple of the settings that I made. I'll go to API key, and I will go ahead and create the presenter. I'm going to add it to my usage plan, basic. Going to go ahead and do this. And gonna go back to the gateway, into stage, and make sure that I get the correct link. All right. Cool. This was expected.
As well.
This was expected. Okay. So you're going to see message internal server. It will default to returning the type application /JSON. Right now it just says hello from Lambda. That is not strictly JSON. It needs a couple things. It needs a static code, and it needs to be within the body. One of the things I really like is that you can do Command S on this, and it won't ask you to save the entire web page, which I do constantly.
Deploy it all.
Nope, because you're not editing the API at all. You're just editing your Lambda.
Great.
So the API will still point to this Lambda, and the Lambda is saved and changed, and it is ready to go. So this should work, and if it doesn't, I'll be embarrassed. Hello from Lambda. Yes, that's also what it is. Okay. So we've already set up the GET request. Part of the thing that I needed to do, I didn't do, and it should not have worked. So that's interesting. So I should have had this in here. Not this.
Oh, right. Yeah,
I'm not sure why it did not let me. And now I'm curious. But XAPI key should have, maybe it's because I'm on the same. Anyways, API key should have prevented me from getting to it. Clearly I need to configure this a little better. Stage, this method. Actually, did I deploy it?
Oh.
No, that's only.
Yeah, I don't know if we deployed after we changed it to true.
Yeah, I think that might be the case. Let's see. Nope. All right. Well, that's a little embarrassing. Anyways, there definitely is a way to do that. I've done it before. And I'm a little disappointed that's not working now. But it does work.
Not allowed to do a live demo without something being weird.
Yeah. Dang, I thought I had everything wrapped up too. My notes lied to me. Okay. Well, so let's just do this functional quick. How much time do we have? Oh, that is actually later than I thought. So, all right. Rather than live code this, I'm going to take the pre-cooked chicken out of the oven that I did beforehand, and go ahead and do this because we're actually nearing 8 o'clock, which is surprising. Oh, I already have you. Okay.
What's the little yellow?
So it's actually, what? Oh, dumb. Yeah, it'll show you when something's wrong. So, well, a little bit. Yeah. So you can see, oh, and actually I can show you. Let me go back and put that in. So I logged the event because I wasn't sure what was gonna happen entirely. Oh, crap. Notes are failing me again. So one of the things that I needed to do, get by name, is that we need the name. Get requests, we're gonna do a string query parameter. String parameter.
Oh.
So we are gonna add name here. You can require it. I have something in my code checking it, so real quick, because I don't have, so I'm gonna leave it like this. But this is crucial if you need your query string. So when you do this, David. Oh, now you work. AWS is just kind of conspiring to embarrass me right now. I think that's kind of what's going on.
Yeah. Ooh.
Kind of skipping ahead several steps, but essentially, that's kind of how you put the method together. There's a bit of configuration to do, clearly. There's a bit of, testing to see kind of how far you can go with some of your methods. But essentially, a lot of that is just setting up your API and API gateway. Once you set up a method that hooks up to Lambda, it's pretty much just writing Node, or Python, or Java, or C#. If for whatever reason you want to do any of those. But in the end, it's just kind of an easy thing to do, an easy thing to set up. Requesting something on a REST API has always been, an event. So if you have something hosted, ready to, connect to whatever database you have set up, whatever third-party API you have set up, it just makes things kind of a lot easier. Especially if, that's kind of all you need the API for. There have been a lot of times where I just needed APIs, specifically a layer, to either combine two separate sources of data, or that needed multiple instances of kind of nearly the same function pointed at it. There was a perfect instance where I could have used this, where we were making a very similar app, both a mobile native and a web app. So this small layer that connected to our shared database, as well as a needed third-party API. Fairly easy to implement, and it was actually for something with a literal off season. So a lot of the time, their hosted database, which they did in a dedicated server with Spring Boot, is not going to be used pretty much at all. So there are a lot of specific use cases for it. Despite whatever small troubles I had tonight, we were able to set up minus actually writing the code, which didn't take me long at all. A pretty simple REST API. So yeah, I recommend it. Yeah, that was my demo. So yeah, just real quick, I mentioned them quickly in the a little bit before. There are a couple alternatives. Google Cloud Functions. I don't think those are ready yet, based on kind of what I've been researching. They will not do the same thing as Lambda, but they are integrated now with Firebase. So if you add something to Firebase, you can actually write a Google Cloud function, and I believe it takes place, I want to say after something is added to Firebase. So there are things you can do with that. Obviously, there's not going to be, it's not as powerful as something that takes it, looks at something before it's changed. But there's still something there, and I don't doubt that they will have something more robust pretty soon. Microsoft Azure, or however you pronounce it, has some Google Cloud Functions. I believe they have the widest range of languages available. But that actually might be IBM OpenWhisk, which is now, I believe, Apache OpenWhisk, as of earlier last month. Now that one is open sourced. It can actually be triggered by functions that are outside of IBM's cloud infrastructure. And I believe you can bring your own, essentially you can bring your own event provider. I believe it works with Docker to trigger some of the functions that it does within the cloud. So any major cloud service is already developing a lot of kind of what you saw today. And so I expect these will get a little bit more robust in the future. Right now, specifically, especially for what I showed this evening, Amazon is probably your best bet. But keep an eye out for these. And in terms of OpenWhisk, you can contribute to it. And OpenWhisk also uses Swift if you're, once again, mobile inclined, like I've been. Here are a couple resources. If I post these slides, I will add a couple more.
What do you mean if?
When I post these slides, well, there's not a whole lot on the slides, to be honest. I'll post a few more. There are some good resources out there. This is a very long video about, and it goes into more computer science-y kind of stuff with it. So it's pretty good. And this is just the docs. But yeah, other than that, are there any questions? I think, yeah.
So Windows are stateless, but you've got a database that can authentication. If you run a bookstore and I bought a set of books and they bought a set of books, like how could you use Lambdas to make sure that we can go in and download our books without being able to download each other's stuff?
Yeah. So yeah, you could do custom authorizers with that. I mentioned those a little bit earlier. So ostensibly, you should be able to, in essence, you could essentially send a request, say with a user ID, send it into a custom authorizer, and say, look up kind of what you're trying to download, and try and match the user IDs before you actually get to the endpoint. You can also just do that in pretty much, essentially in the body of whatever endpoint you're trying to do. But yeah, certainly there are ways to stop them before they even get to the endpoint. If it's more broad, like a set of authors versus readers, authors can download any book, but authors can download any book for some reason, and readers can only download certain books. You could actually what keys you give them, and they could be put on certain usage plans, and then not a lot. They could be denied certain endpoints as well. So I think there are a couple options. Just depends on where you want to put that logic. I hope that answers your question. Anything else? Okay, well, thanks for putting up with me.
Oh, I said earlier that we had all been here a few times, but really, this is Alyssa's first time at the API. Finally did it. Up to date, David, with like, what's new in Lambda? Like, have you joined any kind of groups?
I